Hello everyone, I am Rahul sir, your management educator. Welcome to Global Online Platform. As you know that our crash course on most important topic of management is going, and we have started with the unit number 8, statistics and operations. In today's lecture, we are going to discuss the measures of dispersion. This is one of the important topic. Sometimes a formula based or property based question is asked from this topic. So as we have covered, just a second. So before starting, there is important information for you that the UGC NET exam 2022 is very close now. Very less time is remaining. So this is the best time to take the advantage. If you take this UGC NET paper to management course, you will get complete video lectures, full syllabus, notes, test series, PYQ PDF with detailed explanation. The biggest advantage of this course is if you take the paper 2 course, you will get paper 1 totally free with all the same advantage which are available here. This is all the content which we have added for you for your last minute target based preparation. It is provided in most comprehensive and structured way. So you just have to download this global online app. After downloading, you will get the after login, you will get this home interface. In home interface, you will see the store button and store button in just a second. In the store button, you can get the UGC NET paper to management. After paying, all your queries will be resolved. So now we are starting with the measures of dispersion. Then let's understand what is dispersion. Dispersion is a state of getting dispersed or spread. Statistical dispersion means that the extent to which the numerical data is likely to vary about an average value. In other words, dispersion helps to understand the distribution of the data. Whatever dispersion simply means that whatever the scatteredness, whatever the variations are there, how far the value is from the center value, it is called as dispersion. Okay. Now we have different measures of dispersion. These are categorized under 2 parts. Like measures of central tendency was classified in 2 parts, like positional average and one was mathematical average. These were the 2 classification in 2 categories in central tendency. Now here absolute measures are there and relative measures are there. So in absolute measure, we have RQMS. RQMS means range, quartile deviation, mean deviation, mean or absolute deviation, and standard deviation. These 4 are the absolute measures. But here, when you will add the word coefficient, it will become a relative measure. So coefficient of variation, coefficient of quartile deviation, then coefficient of mean deviation and standard deviation. These are the 4 relative measures of quartile dispersion. Okay. Now this is the most comprehensive chart. Here you can see all the sort of formulas are given related to all the absolute measure and relative measure. Let's discuss one by one. I am discussing in advance so that you can get quick glimpse. When we discuss the concept, there also I have added us one slide. So range is what? Largest minus smallest value, the most simplest one. Quartile deviation is QD is equal to Q3 minus Q1 upon 2. Then we have mean deviation. MD is equal to summation F1 whole bracket X1 minus X bar bracket close divided by summation Fi, means sum of total observation. Then standard deviation. SD is denoted by sigma. Here under root we have F1 into X1 minus X bar whole square divided by n. Then we have variance. Variance is what? Sigma square. Sigma square M is equal to summation F1 X minus X bar square divided by summation Fi. Then if we talk about the relative measures, here all these were we discussed are absolute measures. Now we will deal with the relative measures. For coefficient of range, you just have to largest minus smallest divided by largest plus smallest. Then in case of quartile deviation, we have Q3 minus Q1 divided by Q3 plus Q1. Then coefficient of mean deviation, MD divided by median. Then coefficient of SD divided by mean into is equal to sigma divided by x bar. This is represented symbolically in here. Here it is represented symbolically, and here it's words it is mentioned. Okay. Then coefficient of variance CV is sigma upon x bar into 100, means standard deviation upon mean into 100. So I hope a quick revision of formula is done here. Now we start one by one. The range is the simplest quantity that can be used to measure the degree of dispersion spread in the given data values. It is defined as the difference between the largest and the smallest value in the given data set. In the given data set, whatever the difference is between the largest value and the smallest value, it is termed as range. Okay. Then we have some properties of range. What are these properties? Let's understand one by one. So range is what? The values of range is always non-negative. Range cannot be negative. It will be always positive. Okay. Then the value of the range equals to 0 if and only if the given set of data cells are all equal to each other. Each other means all the values are identical in the data set, then only the range will be 0. Suppose you have to calculate this range 3, 3, 3, 3, 3, or this type of data you have, you can the range will be, value of the range will be 0. But in case here you have 3, 7, 8, 9, 10. So here you can easily determine largest minus smallest, that is 7 is your range. Okay, I hope this is clear. This point is because most of the time in statistics, properties and formulas, these are only the two things, or sometimes assumptions. In case of hypothesis testing, assumptions are the made base, or correlation in such topics, the assumptions are made for base for the questions. Only AF means assumptions, formulas and properties are made base for the question. Okay. Then point number 3, if the range is non-zero, we can conclude that the given data values are not all equal to each other. Means if the range is any number regarding except the negative or 0, the values will be different. They will not be identical. Okay. The fourth one, for the continuous frequency distribution, we can find the range by subtracting the lowest limit of the smallest class from the upper limit of the highest class. You can just find the range by subtracting the lower limit of the smallest class and upper limit of the highest class. Okay. Then point 5 is what is the fifth one, that when finding the range from the frequency distribution, we do not consider the frequencies of the classes. While calculating the range, we don't consider the frequencies of the class, only the upper limits and lower limits of the respective highest and the smallest classes are considered. Okay. Then the sixth one is the value of the range is independent of change of origin. The value of the this point is important because these types of statements become base for statement wise question. The value of the range is independent of change in origin, means there will be no impact of any addition or subtraction in the data set on range. Then we have range formula. The formula of the range is maximum value minus minimum value. Range is what just we have seen, largest minus smallest value. Then how to determine the coefficient of range? It is simply L minus S divided by L plus L. So that was all about your range. I hope you understood. We are running fast because it's a crash course and we have to cover a number of things. I hope you are understanding. The mean deviation is defined as the statistical measure that is used to calculate the average deviation from the mean value of the given data set. Here, what we are doing, mean deviation means what? Here we are calculating the dispersion through, or the deviations in the value through by using the mean. Mean deviation is also called as average deviation. Okay, because we are calculating it from the mean. So it is also called as average deviation. The mean deviation is the data values can easily be calculated using the below procedure. Here, what we will do, first we will find the actual data average and then we will find a deviation. Okay, then let's understand the properties of mean deviation. The mean deviation values, its minimum value when the deviations are taken from the median. The value of the mean deviation will be minimum when it are taken from the median. Okay, then the mean deviation remains unchanged due to the change in origin, but changes same due to the change in scale. Means it simply means that there will be no impact of any addition or subtraction on the mean deviation, but it will be affected by change in any sort of multiplication or division. Okay, then if the y is equal to a plus bx and a and b are constants, okay, constants, then the md of y is b into md of x. Okay, then third one is it is rigidly defined. Mean deviation is rigidly defined. Fourth point is it is based on all observations and not much affected by sampling fluctuations. If any sort of sampling fluctuation is happening, it will not impact the mean deviation to large extent. Okay, then we have point 5, that is it's difficult to comprehend its computation. The computation of means, it's quite difficult to comprehend. Okay, then point 6 is furthermore, unlike standard deviation, mean deviation does not possess mathematical properties. The mean deviation does not possess such mathematical properties like standard deviation, because generally what we eliminate the signs. Here this sign is basically used, x minus x bar. This is what? This the negative sign will be converted to positive here. So the signs will not be considered. That was the biggest drawback of mean deviation, for which the standard deviation was came to overcome this weakness. Here, let's see the formula of mean deviation. For ungrouped data, we have about mean. If you want to calculate the mean deviation about mean, you will just see the x1 minus mean divided by n. Okay, then for about median, if you want to calculate, then x minus median, summation of x minus median divided by n. Okay, then if you have the group data, when you have having the group data, what you will do, summation f1 x1 minus mean, signs will not be considered, divided by summation f1, divided by frequency, summation of frequency will be in case of mean. Then if you want to calculate from median, in case of while calculating from median, r is equal to 1 and summation f bracket x1 minus median divided by summation f1. I hope these formulas are clear. I will suggest you to just write the formulas whenever it is coming, so that it will be helpful for you to recall at the last minute. Now, let's see. I failed to give the heading, sorry. Here we are discussing the quartile deviation. Mean deviation is over. Now we are discussing the quartile deviation. The quartile deviation can be defined as mathematically as half of the difference between the upper and lower quartile. Upper quartile, the difference between half of the upper quartile and lower quartile is called as quartile deviation. Okay, here the quartile deviation is a representation of QD. Q3 denotes the upper quartile and Q1 denotes the lower quartile. Okay, Q3 will denote the upper quartile, because 3 is what? 3 is big number. So it will denote the upper quartile. But Q1 is what? Q1 is lower, smaller number. So it will represent the lower quartile. I am telling this because sometimes many people fail to understand what is which Q is either Q1 is upper quartile or Q3 is upper quartile. They might get confused. That's why I am telling you this trick to remember that Q3 is bigger number, so it will be upper quartile, and Q1 is smaller number, 1 is smaller number, so it will be lower quartile. Okay, then quartile deviation is also known as semi-interquartile range. Quartile deviation will also known as semi-interquartile range. Then quartile deviation formula. Suppose Q1 is the lower quartile, Q2 is the median, Q2 is also median. What is the in terms of quartile deviation, the value of Q2 will be called as median. Okay, and Q3 is the upper quartile for the given data set. For the given data set, Q3 is the upper quartile. Then its quartile deviation of formula is simply mentioned here, Q3 minus Q1 divided by 2. Okay, this is the formula of quartile deviation, Q3 minus Q1 divided by 2. Let's see here the quartile deviation formula is more expressed in elaborative way. Q3 minus Q1 divided by 2. Then the how to determine the coefficient of quartile deviation. Coefficient of the quartile deviation can be is calculated by Q3 minus Q1 divided by Q3 plus Q1. Then we have lower quartile Q1 is equal to n plus 1 into 1 by 4. N by 1 by 4 when you will do, it will give you the value of lower quartile. Then to find out the middle quartile, you just have to n plus 1 divided by 2 by 4. Okay, or it simply means to find out this n plus 1 divided by 4, because this will what? This will be 1 by 2. So n plus 1 divided by 2, middle quartile, it is median. Q2 will be will be called as median. Okay, let me write. This will be the value of median. Then we have upper quartile. Upper quartile Q3, it will be calculated as n plus 1 into 3 by 4. Okay. So these are, this was all about quartile deviation. Let's come to standard deviation. Now we are discussing the standard deviation. Standard deviation was given by Carl Pearson. He may be using Pierce soap. That's why he's known as his name is Carl Pearson. Okay, jokes apart, because now let's understand standard deviation. It was coined by Carl Pearson, and it is also called as root mean square deviation. Because why? Because we are using root sign to calculate the standard deviation. So it is also called as root mean square deviation. Then a standard deviation is denoted by sigma. Remember this sign, sigma is used to denote the value of standard deviation. Then it's a measure of how dispersed data in relation to the mean. Low standard deviation means how the value of how far is the value from the, it is from the mean told by the standard deviation. Then low standard deviation means the data are clustered around the mean. When the values are close towards the mean, it will be the value of standard deviation will be low. Okay, and when the value of standard deviation will be high, the data is more spread out. There, the value is away from the mean. When the values are away from the mean, then the value of standard deviation will be less. Okay, when the other data is away from the mean, spread out will be there. It will be denoted by the greater value of standard deviation. I hope this is clear. Another name for standard deviation is root mean square deviation, and it was coined by Carl Pearson. So let's understand the properties. Properties, it cannot be negative. Standard deviation can't be negative because their dispersion always exists. Then it is only used to measure the spread or dispersion around the mean of the data set. In case of mean deviation, we were using median and mean to calculate the mean deviation, but to find out the dispersion or scatteredness. But here, or spread. But here, in case of standard deviation, only mean will be used to find out the spread or dispersion. Okay. It shows how much variation or dispersion exists from the average value. How much dispersion exists from the standard average value, it will be told by standard deviation. Then it is sensitive to outlier. Standard deviation is affected by extreme values. A single outlier can raise and in turn distort the picture of spread. Okay, means outlier means what? Extreme values. Then 0.5. Fifth one is for data with almost the same mean. If a data set where the mean is same, the greater the spread, the greater the standard deviation. Where almost the same mean is there, the greater, if the spread is greater, the value will be the value of standard deviation will be greater. Then 0.6 we have standard deviation can be used in conjunction with the mean in order to calculate the data intervals when the analysis normally distributed data. When the normal distribution, when the data is normally distributed and it is analyzed, so In case of mean, in order to calculate the intervals, in case of interval based data, we use standard deviation to conduct the dispersion. Now, here is the formula of standard deviation, that is sigma is equal to under root mean minus summation of x minus mean square divided by n. Okay. Then here x is the set of numbers, then mean is the average of the set of numbers, then n is the size of the set, means summation of the frequencies, and sigma is the standard deviation. Okay. So I hope this formula is clear. Then this is the quartile division formula again, Q3 minus Q1 divided by 2. I will suggest you, let me go back, to take the screenshot. You should take the screenshot of this slide, because here all the formula are given in a crispy way, and it will help you to memorize by simply watching the simply studying the screenshot twice, thrice. You will be able to recall all the formula in exam. Let's understand what is variance. The term variance refers to the statistical measure of the spread between the numbers in a data set. What is the statistical measure? Is again checks the spread. Okay, most specifically, variance measure how far each number in the set is from the mean, and thus form the very other number in the same set. Means whatever the it's again saying the same thing, that it specifically measures how far is the mean is the numbers are there from the mean. Okay, from the every other number. Variance is often depicted by the symbol of sigma square. Okay, sigma square, and the sign sigma square is used to as a symbol of median. Okay, just a second. This is the sign for this representing the variance. Okay, it is used by both analysts and traders. It is used by both analysts and traders to determine the volatility and market security. As when we were discussing the our CAPM model, there we have seen that sigma sign was there. But here is what that was only the standard deviation. What it was representing? It was representing the systematic risk. Okay, so here the analysts and traders both use this variance. Okay, then the square root of variance is the standard deviation. When we take the under root of variance, it will give you the standard deviation, which helps to determine the consistency of in investments returns over the period of time. The standard deviation tells the consistency, how consistent return you will get over a period of time. Okay, so that's all about the variance. Here is the formula. Variance square is equal to summation f1 into x1 minus x bar whole square divided by summation f1, and the coefficient of variance divided by some sigma divided by x bar, means SD divided by mean into 100. Now we have skewness. Their measurements of skewness. Skewness means what? When the value of mean, median, and mode are not equal. When both are not equal, there are some when these three values are not equal, mean, mode, median, in case of a normal distribution curve, then there exists some skewness. Then measures of skewness is used to determine the difference between the mean, median, and mode in distribution. The following table summarize it. So let's understand from here. Mean minus mode. If the difference between mean, median, mean minus mode is greater than 0, that is, which is, if it is positive, then the distribution is skewed to the right or positively skewed. When the mean minus mode difference is greater than 0, there will be the NDC will be rightward skewed, or it will be positive skewed. When mean minus median is less than 0, then the NDC will be, NDC means the normally distribution curve will be skewed to the left, and it will be called as negatively skewed. And if the mean minus median mode is equal to 0, it will be symmetrical, that the distribution will be symmetrical. Here any sort of skewness will not exist. Now let's understand one by one. So here indicates the positive skewness, where when it is skewed to the right, then this is the best one, where all the three values of x, m, z are equal. X is equal to m equal to z. X is the mean, m is the median, and z is the mode. Okay. Now this is the symmetrical distribution, is the representative of binomial. Not binomial. It's the representation of normal distribution curve. Okay, then when the distribution is negatively skewed, it will be skewed towards the left. I hope